Good day, everyone. Our case study is all about the study of the design methodologies of steel column bases by Piana and Calinsani. But before we start, here is our group reporters. Your truly yours, Jay Banglos, Miss Rina Melmeda, Mr. Janus Mulu, Miss Algin Mutia, and last, Miss Tom Anjitan. Abstract. The behavior of steel structure is directly related to the type of base used in the columns, which is essential to the stability and security of the structural system. The Brazilian standard does not directly cover this subject. Another Brazilian standard presents a limited design procedure to hollow columns. In this paper, two design methodologies are presented considering the uniform and triangular pressure distribution between the base plate and the concrete surface. A computational program has been developed to design steel column bases considering both methodologies mentioned. The program has been validated with manually solved design examples and conclusions about the pressure distribution design procedures were made from the 200 bases designed by the program. It was noted that for the triangular pressure distribution, there is an interval in which the procedure is not completely applicable. Apart from this interval, there was no significant difference in the results. An introduction. Column bases are used as a steel concrete interface between steel columns and their foundations. Their main function is to transmit the structure's stresses to the concrete footing surface and to link the column bottom end to the footing. So column bases include base plate, anchor rods, and shear-resistant element such as the shear lugs. As you can see in illustration figure 1, there is a base plate, grout, concrete footing, shear lug in this center, steel column, washer and thread, anchor rod. So in figure 1, components of steel column base adapted by fissures and clover. So, steel connections are extremely important to steel structures. The connections are the ones who are ensuring the structure stability and must realize the best possible way the type of internal link considered in the design. So, Brazilian Standard 8800-2008 does not directly cover steel column base connections and takes the reader to design guide by Fisher and Kloiber. Another Brazilian standard, ABNT NBR 16239-2013 include this subject, although it is limited to hollow steel column bases. Other writers such as Belay and Biafilo and Silva do not present the stress case of combined tensile axial loads and moment. Additionally, most texts about this kind of connection consider a triangular pressure distribution between the concrete and the base plate. So, ABNT NBR's 16239-2013, however, considers a uniform pressure distribution. So, therefore, scientific literature lacks more research articles on the design of steel column bases according to the newer Brazilian technical guides, the NBRs, and that presents a more complete content about the requiring strengths at the plates. So this study had as a goal to automate the design of steel column bases following Brazilian technical standards, considering both triangular and uniform pressure distribution. So additionally, the design of column bases considering triangular and uniform pressure distributions were compared. So There are 5 different types of steel column bases were considered. So first is the plain W-shaped column base and with no moment transfer to the footing. So wala siya yung moment transfer to the footing. Then the next is the fixed W-shaped column base with moment na siya, with moment transferred to the footing. So ang plain W-shaped column base with no moment transferred siya to the footing. So there is a fixed W-shaped column base na siya yung moment to transfer to the footing. In rectangular hollow column base, so muna siya. Muna yung figure. sorry. So next is the circular hollow column with triangular plate base. So muna ang circular hollow column niya. Then ang iyang base plate muna ang rectangular base plate niya. So and last, circular hollow column with circular base plate. So muna yung circular hollow, iyang base plate mo po niya circular hollow. So usually column bases are subject to compressions or tensile forces, flexural moment, and shear forces that can induce the following limit state. So mga following limit states niya are crushing from the concrete in contact with the base plate. So muna siya usa. And next is formation of plastic hinge mechanism in the base plate. So another one po na. Then yielding of the anchor rod in tension, sliding of the base, anchor rod concrete pull out, among others that will not be covered in this text. So wala na covered din sa text. So for the base design of W-shaped column, the procedure presented in this text is based on the design guide of Fisher and Clover. So since ABNT NBR 8800/2008 does not present a design procedure for a column base, so kani siyang pin W-shaped column bases. So does not design daw does not present a design procedure for column bases, base plates. So for the base design of hollow columns, so kaning hollow columns, kaning tire, makita daw nato ni siya sa makita daw nato ni siya sa ABNT NBR 16239 shape column 2013. So next is the statement of the problem. So the problems address the development of a comprehensive and practical approach for designing steel column bases. So the author recognized that column bases play a critical role in the stability of the steel structures. So under design requires careful consideration of a range of factors, including the load distribution, so the type connections, the material used, and the geometry of the base. Despite the importance of this aspect of structural design, so the authors note that there is a lack of consensus and standardizations in the industry regarding the design methodologies for steel column bases. As such, the paper seeks to address this gap by presenting a detailed review of existing design methodologies and proposing a new methodology that considers various design aspects and provides a practical approach for designing steel column bases. So these are the objectives of the study. So this paper aims to evaluate and compare different design methodologies for steel column bases, which are critical components in steel structures, The study aims to provide comprehensive review of the current design methodologies for steel column bases, both traditional and innovative methods, and to evaluate their accuracy and efficiency in predicting the behavior and performance of steel column bases under various loading conditions. So, specifically, the study seeks to achieve the following objectives. So, first is to identify the different design methodologies that are currently used for steel column bases and provide a detailed analysis of their advantages and disadvantages. So next is evaluate the performance of these design methodologies in terms of their accuracy, efficiency, and ease of use. So next is to analyze the factors that influence the selection basis, such as the type of loading, the size of the column, and the structural configuration. Next is to provide the recommendations for the selection of the most appropriate design methodologies for steel column bases based on the specific requirements of a given project. So, to identify gaps in the current knowledge of design and suggest areas for future research. And last is to develop design guidelines and codes of steel column bases that are specific to the Brazilian context. This involves considering local construction practices, materials, and codes and standards, as well as the unique loading conditions that structures in Brazil may experience. So, the significance of the study. This paper lies in its contribution to the development of more efficient and accurate design methodologies for steel column bases. This can lead to the optimization of steel structures, resulting in cost saving and improved safety. Additionally, the finding of the study can be served as reference for practicing engineers, structural engineers, architects, and other professionals involved in building designs and construction. They can help improve the design steel column bases, leading to safer and more efficient buildings. Scope and limitation. The scope of the study is to review the existing design methodologies of steel column bases, including their advantages and disadvantages that can improve the structural performance and reliability of steel column bases. The limitation of the study include the fact that it only considers steel column bases and does not cover other types of column bases such as concrete or timber. The study is also limited to the evaluation of the design methodologies and does not cover the other aspects of column-based design such as fabrication, installations, and maintenance. Additionally, the study is limited to a review of existing literatures and experimental tests and does not include any numerical simulation or case study. So, in terminologies, steel column bases, it is the foundation of a steel column that transfers the load of the column to the foundation of the structures. Axial load, it is the vertical load acting on the column along its longitudinal axis. Anchor bolts, used to anchor the column bases to the foundation. So, grout, a mixture of cement, water, and sand or gravel, used to fill the gap between the column base and the concrete. So, base software, develop software that design base plate, anchor rods, and their location at the plate, shear leg, and minimum dimension for the concrete element that is going to receive the steel column. Shear resistance, the ability of a connection to resist shear forces. Design methodologies, the systematic and structural approaches used to solve a problem or achieve a desired outcome, in particular field of discipline. And computational program developed to design stair column bases considering methodologies mentioned is a set of instructions or code that a computer can understand and execute to perform a specific task. So, and that's all. Thank you.
Good day, everyone. By the way, I'm Reina Esmalmida. At this point, I'm going to present to you our review of related literature that support our chosen topic regarding to the study of design methodologies of steel column bases. In the year of 2021, as examined by N.J. Lanchette et al., economy load carrying capacity of all structural parts and safety precaution, this research compared the cost-effectiveness of using tabular sections versus traditional sections for the same workload. The goal of this comparison is to examine the superstructure of an industrial building. The use of tabular section has been shown to save costs by as much as half, according to the research. Existing building response to seismic loads was studied by A.E. Ashabala, published in the year of 2019, suggests that seismic displacement and stresses were determined by analyzing the frame with the response spectrum approach. The acquired result demonstrate unmistakable that the nodal displacement result in drifts that were twice or thrice permissible values. Ground floor column compressive stress were approximately 1.2 to 2 times the tensile stresses, and the horizontal motion had a bigger effect on the axial compression loads of the outer columns than interior columns. Beams B805, B806, and B807 were found to experience shear force owing to L-C3 that were around 4 times greater than those related to L-C1. Beams experienced roughly the same maximum compressive and tensile loads. Seismic execution result in substantial higher values for bending moments in beam and columns than static stresses. Moreover, Manand Maheshwari, published in the year of 2018, studies that for both static and seismic loads, the analysis was carried out horizontal earthquakes motion with moderate peak ground acceleration was used in seismic study. All checks for both the truss and portal frame are made using draft code IS 800.2007 and IS 806 for limit state design of the given problem with conventional and tabular steel sections, respectively. So this multi-span industrial shed was designed STAAD through V8I, a structural analysis program, double-check data that was manually evaluated, steel consumption for truss and portal frame section is tailored to show the combined outcome of the two section types. And that would be all for the chapter 2. And we will proceed to the next chapter.
Results and discussion. A 200 double-shaped column bases were designed in the developed software. So the first 100 bases subject to tensile force with moment, and the last 100 to compression force with moment. So the goal was to compare the results of the designed base plate subject to moment, considering both hypotheses of contact pressure distribution, uniform and triangular. So all calculated bases had the following common features. Base type be a figure 2, AST and A36 steel for base plates and anchor bolts, C20 concrete, and 4 anchor rods per plate. So given the large amount of information about the 200 column basis calculated, it is not possible to present all input and output data. Therefore, in Table 2, we selected some of the bases designed with tensile force with moment and presented their respective results. So here, this is the Table 2 basis design considering tensile force with moment. This is a sample results, and we have here the input data and results. The input data, we have sample size, its type of base plate, request, hypothesis. And sa results, we have base plate, anchor rods. So as you can see sa anchor rods, ang diameter o ang iyahang bearing length are all 0%. Some bases subject to tension with moment did not provide plate thickness values. It was observed that this situation always occurred for the triangular hypothesis of stress distribution. So when analyzing the design of this basis in particular, it was noticed that all these cases were bases with large moment, and that the reason why the program did not return values was because the variable LC, which is the bearing length that represents between the plate and the concrete, acquired a negative value, which is inconsistent for a distance. So this is the figure 15. Basis into eccentricity interval is not covered by triangular contact pressure hypothesis. So this is figure 15A, which is plate subject to compression. Ang kaning figure 15B, kani siya is subject to tension. So this was due to the factor E minus A. Why ang kaning bearing length between the plate and the concrete acquired a negative value, which is inconsistent for a distance. So the reason why it's negative, because it was due to the factor E minus A used in the calculation of LC returning a negative value. So these results indicate a failure in the design procedure of base subject to tensile with large moment and triangular contact pressure distribution, showing that the formulation in this case is only valid when E is greater than A. So analyzing the results of the bases subject to compression with moment, inconsistencies are also observed in the triangular hypothesis of contact pressure distribution. So although the inconsistencies were not as clearly indicated in the results as in the case of basis subject to tension with moment, it was observed also that in some cases the strength in the anchor acquired a negative value. That is, the anchors were not drawn. So this result is inconsistent because the base is considered subject to compression with large moment, and the fact that there is no tensile force in the anchor rods makes the base a case of compression with a small moment. So the inconsistency was not detected in the thickness results of the base plate, since its value is given by the greater of the value determined by equation 24 and 35, which verify respectively. So the plate bending caused by the tensile force at the anchor rods, and the bending at the plate caused by the contact pressure. As illustrated in figure 15A, creating a interval for which neither the compression with small moment procedure nor the compression with large moment procedure apply. So when classifying a base as compressed with large moment, bearing stresses are considered in part of the plate. Note that the triangle distribution method does not admit that the force with equivalent eccentricity may be outside the region of the inertia centroidal kernel without bearing pressure at the plate, as shown in figure 15b. This one. Analyzing the plots of figure 16 about the area of the base plates, it can be seen that the bases subject to tensile force and moment present a smaller dispersion in the area value. That is, the hypothesis, uniform and linear, give results closer to those observed in the moment compressed bases. This is because in bases with tensile force, there is only a difference between the methodologies when there are bearing pressure between the plate and the concrete, which is bases with tension and large moment. So this is the figure 16 perfect adjust line graphic for the base plates area. So here, A is the perfect adjust line area of the plate subject to tensile force with moment. And si graph sa B, it is a perfect adjust line area of the plate subject to compression force with moment. So in the compressed bases, there are contact stresses in both cases. Compressed bases with small moment and with large moment. So in the case of the bases with tension and moment, the triangular hypothesis guaranteed a larger area with an average percentage differences of negative 1.35%. So in the case of compressed bases with moment, the uniform hypothesis guaranteed larger area with an average percentage equal to 3.31%. So sa figure 17, hypothesis comparison for the design of base plates area. So in order to compare the design hypothesis, perfect fit line plots were drawn. So figures 16 to 18, contemplating the analysis of the dimensions of the base plates by means of the results for area and thickness and of the anchors by means of their diameter. So the percentage difference average indicated in the plot is given in relation to the dimensions obtained by the uniform hypothesis. So this is figure 17, hypothesis comparison for the design of base plates area. So sa A, base subject to tensile with moment. So here's ang differences niya. Ang no differences is 78%, while ang area larger in uniform hypothesis is 5%, and area is larger in triangular hypothesis is 17%. So sa B, basis subject siya sa compression with moment. Ang iyang no differences is 21%, while its area is larger in uniform hypothesis is 43%, and while also sa area is larger in triangular hypothesis, iyahang percentage is 36%. So that's it. If the average is positive, it means that the uniform hypothesis presented a value greater than that of the linear hypothesis, and vice versa. So the bases that had their results considered inconsistent were disregarded. Thus, of the 100 bases subject to tensile force with moment that were processed by the software, 76 were analyzed, and of the 100 subject to compression with moment, 92 were analyzed. So sa figure 17, it is noted that in 78% of the bases, there was no difference between the methods and the value of the calculated areas. And that is why a large part of the points in figure 16 in A are above the perfect fit line, and also possibly there are overlapping points with the same area value. In the case of compressed air bases with moment, only 21% of the bases in figure 17 presented the same area value in both methods. So fewer points are on the perfect fit line, which is also showed in figure 16b. So connected ra ang figure 16 and figure 17b. Figure 17. So the triangular hypothesis guaranteed a larger area, which is 17% of the basis for the fraction basis. So if in the case of compressed basis, the uniform hypothesis guaranteed a larger area, which is 42% of basis. This is the figure 18, perfect adjust line graphic for the base plate thickness. So as you can see, sa A, it is a perfect adjust line thickness of the plate subject to tensile force with moment. Sa B, ano siya, subject siya sa compression force with moment. So figure 18, analyze the thickness of the base plate plot. In both cases, tensioned and compressed with moment. So the hypothesis of uniform distribution provided a greater value for the thickness of the base plates, with the average of the larger percentage differences in the bases compressed equal to 5.79% against 1.24% in the bases with tension. So therefore, there was also greater dispersion among the methodologies in the compacted bases with moment. So this is the figure 19 hypothesis comparison for the design of base plate thickness. So assumption siya sa design of base plate thickness. So here, this, it shows the the difference. I mean the comparison of the thickness is larger in triangular hypothesis, which is 45%. Ang no differences niya is 24%. Thickness is larger in uniform hypothesis, which is 31%. Sa PCAS, ang iyahang thickness is larger in triangular hypothesis, 27%, while sa PCAS is 45%. And no differences niya is 2%, while the other one is 24%. So sa thickness is larger in uniform hypothesis na ay 71%, while the other one is 31% lang. So when analyzing figure 19, it can be seen that in only 24% of the bases with tensile force and in 2% of the compressed bases. So the two methodologies provided identical results. So the triangular hypothesis guaranteed a greater thickness in 45% of the bases with tensile, and in case of compressed bases, the uniform hypothesis guaranteed a greater thickness in 71% of the bases. This is the figure 20, perfect adjust line graphics for the anchor rod diameter. This is also same sa previous na figure. Sa A nga figure 28, this line is subject to tensile while the other one is subject to compression, but also napod siya yung moment. So analyzing the plots of figure 20 about the diameter of the anchors, it can be noted that there are few points in this plot because the calculated diameters are presented in commercial dimensions. So which means that there are overlapping points, one above the other. So for the bases with tensile force and moment, there was practically no difference between one methods. So the average percentage differences was only negative 0.51%. So this is the last figure, which is figure 21, hypothesis comparison for the design of anchor rods. So ang no differences niya in the left side is 93%, while the right side 44%. And sa left side, walay diameter is larger in uniform hypothesis. Pero naa siya diameter is larger in triangular hypothesis, which is 7%. While the other side, it is only 47%. The graph of figure 21 shows that in 93% of the bases with tensile force and moment, there was no difference between the methodologies. However, in the 7% in which there was a larger diameter was noticed for linear method. So for the moment compressed bases, the triangular hypothesis guaranteed a greater diameter of the anchor rods. The average of the percentage differences was negative 7.67%, and in 47% of the compressed bases, the triangular hypothesis provided a higher result. In 45% of the campus bases, there was no difference between the methodologies. So according to Fisher and Klorber, they said that the use of the triangular bearing pressure distribution method provides thicker base plates and smaller anchors than the uniform method. So however, the results obtained when scaling bases in the program showed the exact opposite. So for the linear stress distribution method, the plates presented smaller dimensions and the anchor rods, so bigger in relation to the uniform bearing distribution method. So the highest average of the percentage between differences, the hypothesis, being 3.31% for the area and 5.79% for the thickness of the base plates, and negative 7.67% for the diameter of the anchor rods. The existence of the interval for which the triangular bearing pressure distribution is not appropriate together with the low percentage difference average in the interval where two hypotheses were compared makes the hypothesis of the uniform contact stress distribution the best approximation to be used in the design of steel column bases.
3. Methodology 3.1 Computational Implementation. To ease computational implementation, 8 flowcharts were developed. One flowchart illustrates the software structure and the others the basis, design, tensile compression, compression with small moment, tensile with small moment, compression or tensile with large moment, shear, and a flowchart about anchor rods design. The goal was to present the sequence in the order of the main equation necessary to the development of the software. For instance, figure 9 represents the flowchart of tension subject bases. So, in the next slide, I will show you the flowchart, which represents the formula that will be present in order of the main equation necessary for the development of the software. So, the design flowcharts were implemented using Visual Basic language. The tool used for the software development was chosen by the easiness of the interface making procedure called implementation and error debugging. Besides that, it was intended to provide to the academic and professional communities of a software tool of easy access and comprehension. 3.2 About the software developed. The developed software named base, design, base plate, anchor rods and their location at the plate, shear lug, and minimum dimension for the concrete element that is going to receive the steel column. The developed software makes possible the consideration of both uniform and triangular bearing pressure hypothesis and considers the following stress cases at the plate: tensile, compression, tension with moment, and compression with moment. Additionally, the software includes the design of shear strengthening elements. So, as you can see, this is the figure 9, the flowchart that will be supporting the development of the software. These are the equations, figure 9. So these are the software that will be used in our case study. So figure 10. So we just simply put the data here. As you can see, it's not English. So lahi na language ang nagamit. So another software that they use, input the data window of column definition. Next, the software input data are the geometry of the base plate, base type in figure 10, A to E must be selected. So you can see there that the data will be just inputted here in their places. So next, dimension of the W shape or hollow column. The user can choose between the pre-existing columns or input the dimension in figure 11. So same ra sa figure 10. internal forces, figure 12. So next, magulat lang ta sa sunod na slide. So type of shear element, shear log or anchor rods, figure 12. The position of the contact plane between the plate and the concrete surface under the coincidence plates placed directly at the footing or above the concrete surface. The steel yields limit of the base plate and shear log, the steel tensile strength of the anchor rods, and the concrete compressive strength. The user can choose between pre-existing materials or input new properties. The number of anchors at the plate and the type of anchor rod with 90 degrees elbow or with anchor plate at the end. The consideration of the confinement effect or on concrete, ignore the effect dimension, the concrete area considering the maximum confinement effect or enter the pre-existing dimension of the concrete area, figure 13. The software output data are plate dimension, thickness, width and length, and its weight in kilograms. Anchor rods, length and minimum commercial diameter, shear log dimensions. The distances from the center of the anchor rod to the edge of the plate and to the center of the nearest anchor rod, figure 14. So, the minimum horizontal dimension of the concrete footing when the user chooses two dimensions, the concrete area. So, the software output dimension are the minimum values determined for the elements to have a safe design. Therefore, the designer can adopt larger dimensions with the development of this software. The authors intend to provide the academic community a tool of easy use and in accordance with Brazilian design standards prescription, which also enables comparison between the uniform and triangular bearing pressure hypothesis. So these are the software that they're going to use. So these are Brazilian words, as you can see. So magbasa palandaan natin dahil din siya, no? So input data window of forces. So let's just put the values and then voila. So next, input data window of concrete footing surface. Same ra gyapon, mag-input ratag mga value and voila. So output data window of anchor rods locations. So magbutang ra gyapon tag mga value kung asa nato pamutang ang ato ang mga steel and mga diameter or areas dinhi sa ato ang software. Then okay na dayon, maka-design na din ta. So next, 3.3 Software Limitation. The Brazilian standard NBR restricts the number of anchor rods at hollow column bases with rectangular plates 4 to 8 and for circular plates between 8 and 12 anchor rods. Besides that, the largest dimension of the column transversal section is also limited in 510 mm. Because of the software uses the design procedure, it does not design hollow column bases that are out of these specifications. Other limitations of this software are: does not design base plates with stiffeners welded to the plate and the column, does not design base plates with moment in the direction of the similar inertia axis of the column. Consider the column centered in the base plates and the base plates centered in the concrete footing. Does not consider the confinement effect for the concrete strength determination in plates compressed with moment and for shear logs design. Does not consider bending in anchor rods when there are washers welded to the base plate. In case of tensile force at the anchor rods, in the bases type B, C, and D of Figure 2, it is not verified if the lines of distribution of tensions in 45 degrees, starting in the center of the anchor rod, intercept the edge of the base plate. The software does not accept null axial force. The software dimensions just two types of anchor rods, L-bolts and stud welded plates or headed bolts. 3.4 Software presentation. The access of the program windows is done through the input and output data bar located to the left on the screen. The user should enter the data in the input data tabs. So, tipo di base, perfil, esporcos, material, chumbadores, and apio di concreto, and calculating the base. The user can view the results on the output data tabs, placa di base, chumbadores, lucacao, bara di quisalhamento, apio di concreto. To calculate the base, the user must click the Calculate button at the bottom of the data bar and select which calculation method will be used, uniform contact pressure distribution or triangular pressure distribution. As illustration, figure 10 to 14 shows some of the program windows. The program has a database with W-shaped profiles produced by Gerdau Acominas, and with the hollow profiles produced by B&M do Brasil. Only needed to select the profile destination. The diameter of the anchor bolt is calculated by the software and indicated in commercial dimension with a minimum limit of 16 mm. So, kani nga mga words diyan, makita natin siya dito sa mga software na to nga ipakita na ko na sa figure 10 to 14. So, dito na ito ipang input ato ang mga value, then tuslok rin nato atong calculate nga bottom sa ubos ato sa left side, then wala, makita na din ato ang mga design sa ato ang base plate. So, next. So, 3.4 software presentation. In the Apio di Concreto window, figure 13, the user decides whether or not consider the confinement effect on concrete. If the user wants to consider, the user should indicate whether there are already defined dimensions for the concrete area that will receive the base plate, or if the user wants the software to calculate it. If the user wants the program to dimension the concrete area, an area is going to be determined in which the confinement effect provides a maximum concrete strength. So, as you can see, di ba, na ang software ay mag-calculate tanan kung asa dapita pod mapunta ang mga maximum concrete strength. Ito, makita na dito kay tungod sa ilahang ka-high-tech. Software validation. In order to validate all the design procedure related to all different force requirement cases addressed in item 2, it was decided to solve example manually and compare them with the result of the software base. This choice is justified due to the lack of example of column-based design in national literature. In addition, the use of example from the international literature would not be ideal since there would be divergences in result due to differences in safety coefficient, design distance, and profile used in columns in order to elaborate the manually solved examples. The loading were chosen so that the example for each case type was solved. That is, examples of compression with small and large moment and tensile with small and large moment were solved considering both uniform and triangular contact pressure distribution hypothesis according to table 1. So makita na ito na sa ato ang unang reporter. So all tests were solved for W-shaped columns bases with the parameters related to the fixed materials, ASTM A36 steel for base plates, anchor rods, and shear lugs when used, and C20 concrete. The examples considering 4 anchor rods per base plates for all validation tests. So, software validation. Table 1 shows that the solved tests with their respective input data. The first column refers to the base types according to Figure 2. The effect of containment columns informs the consideration of the effect of confinement. Now say applica, when it is not a case of pure compression. Sim, when the effect is considered and the dimension of the concrete element are provided by the user. Ignorado, when no effect is desired. And dimensional, when user wishes to consider the effect of confinement and do not have predefined concrete element dimension. After the resolution of the test in the software base, it was observed that there were practically no deviation between the manual and program result. The result of the test can be observed in Table 1. However, small deviation of the order of 0.01% can be expected due to rounding of the manual calculation. Therefore, the program was considered validated for one profile base plate. So here is the software validation, the results. So table 1, input and output of the data test used for the software validation. So here you can see it, the output of the data that are inputted in the software. So the design of steel columns bases is a complex process that requires careful consideration of load capacity and stiffness requirements. So the use of analytical methods provides different perspectives on the design process, and both have advantages and limitation. So sa empirical kay more on ni siya sa experiment, while ang kaning analytical methods kay more ni siya sa software na high-tech na. So mga paano siya, mathematical models and calculation. So mao ni siya itong mga software na mga nabuhat. So ang gigamit na ni kay analytical methods. So that's all for my
Good day everyone, I am Taman Rigitan, and I was tasked to discuss the conclusion of our case study, which is the study of design methodologies of steel column bases. Conclusion. In this study, a program named BASE for the design of steel column bases was created. It uses two alternative design techniques, uniform and triangular, to take into account the contract pressure distribution. A sizable number of personally solved examples for the various loading scenarios handled have been used to properly validate this software. The program was marketed as a very practical and adaptable solution for automating the design of column bases. The discrepancies found in some of the discussed results indicated a range between small and large eccentricity, for which the triangular stress distribution based design technique is inappropriate. When the findings of two hypotheses of stress distribution were compared, it was found that bases with tension and moment had less dispersion. The average percent difference was negative 1.35% for the area and thickness of the plate and 1.24% for the diameter of the anchor rods. Because the methods for computing these bases differ in the situation of large eccentricity, as opposed to the bases compressed with moment, where the methods vary in both cases, example in small and large eccentricity. This smaller dispersion happen with 3.31% for the area, 5.79% for the thickness of the base plate, and negative 7.67% for the diameter of the anchor rods. The moment compressed bases showed the highest average of percentage differences between the hypotheses. The hypothesis of uniform contact stress distribution is the best approximation to be used in the design of steel column bases. Due to the existence of an interval for which the triangular bearing pressure distribution is inappropriate and the low percentage difference average in the interval where the two hypotheses were compared. So, the hypothesis of uniform contact stress distribution is commonly used in the design of steel column bases. This hypothesis assumes that the pressure distribution between the base plate and the concrete foundation is uniform, which means the load is distributed evenly over the entire contact area. According to the hypothesis, this assumption is the best approximation to be used in the design of steel column bases because there is an interval with the triangular bearing pressure distribution is inappropriate. This means that the triangular distribution, which assumes that the pressure is highest at the center of the contact area and decreases towards the edges, is not accurate in certain situations. Moreover, the comparison between the two hypotheses shows that the percentage difference average is low in the interval where the two hypotheses were compared. This means that the difference in the results obtained using the two hypotheses is not significant, and therefore the hypothesis of uniform contact stress distribution can be used as a reliable approximation in the design of. For recommendations, it is recommended that designers evaluate the requirements and limitations of each design methodology before selecting the most appropriate one for a specific project. So, design methodologies have unique strengths, weaknesses, and requirements that make them better suited for specific types of projects. Thus, designers must evaluate the requirements and limitations of each design methodology before selecting the most appropriate one for a specific project. By doing so, designers can ensure that they choose the most effective methodology that can meet the project goals, objectives, and constraints. Then the second recommendation is the use of computer-aided design tools and software can help designers to evaluate the performance of different column-based designs under various loading conditions and to optimize the design accordingly. So, computer-aided design tools and software can assist designers in creating and analyzing for column bases. These tools allows designers to model the design in a virtual environment and simulate various loading conditions to evaluate the performance of the design. By doing CAD tools, designers can easily test different designs and optimize them based on the results of the simulations. This can help designers to identify potential issues with the design and make necessary adjustments to ensure that the final design will perform well under the expected loading conditions. Overall, the use of CAD tools and software can help designers to create more efficient and effective column-based designs, as they can quickly iterate and analyze different designs in a virtual environment, leading to better design decisions and ultimately reducing costs and risks associated with physical prototyping. So the third recommendation is it is essential to consider the effects of various factors such as the material's properties, column geometry, and the type of loading on the design of column bases. So, when designing a column base, it is important to take into account factors such as material properties, column geometry, and loading type, as they all have an impact on the overall stability and performance of the column. Neglecting any of these factors could lead to failure or reduce efficiency of the column base. And the last recommendation is the use of innovative and sustainable design solutions, such as the use of recycled steel or new construction techniques, should be considered in the design of steel column base. Incorporating innovative and sustainable design solutions, such as using recycled steel or new construction techniques, can enhance the design of steel column bases to make them more environmentally friendly and efficient. This can lead to a reduction in environmental impact and lower costs in the long run.